Okay. Because one of the important topic is networking basics also. So today is a it automatically happens. So I shared already this link to you. Okay. So we will go to one by one networking basics part. First one I want to start. Where is my link? What is network and what is networking? What is internetwork? What is internetworking? Better fresh page. What is network? What is networking? What is internetwork? What is internetworking? Interconnection of two or more devices is called a network. Okay, means we'll see ultrasound diagram here. So carefully look at there. Just for example, what is an interconnection of two or more devices? You are connecting devices together. So I will take small because I need a big space to connect it. Okay. So these are my devices, means my maybe a computer kind of stuff. This is my hub bar as such. Okay. So these are my devices. For example, this is a PC A1, PC B1. When PC is not required word. So I'm connecting like this. This is one way of connecting, guys. There is a different way of connecting. The devices are there. That is also we are going to discuss. So this is a one network. This is a one network. So what I have done? Interconnection of two or more devices. Interconnecting these devices. So then it is become a network. If you make a communication between these devices, means A1 is able to send a message to B1. What happened? Okay, able to send a message to B1. Or is C1 able to send a message to A1? Okay, so this is communication between two or more devices, interconnected devices, is called a networking. Guys, you got it? network. What is a network? It is a interconnection of two or more devices. What is networking? Communication between interconnected devices. Very good. Think like this. This is the PC A2. This is another network. This is another network. Think like it is a network 2. Okay, so we have two different networks are there. Okay, if A2 can able to communicate B2. Okay, we have two networks there. So what is a okay? Want to connect these two different networks. Okay, then we will connect it. For example, okay, so not example, simple interconnection of. Okay, it's a connecting two or more networks. Okay, I have a network 1. This is a one network. This is another network. I want to connect these networks together. It is become internetwork. Okay, it is a interconnection of two or more networks. Somewhere I am missing point. Okay, so it is where it is went somewhere. This should be gone. Okay, what is internetwork? It is a connection of two or more networks. What is internetworking? It's a communication between different networks. See, this is a one network. This is another network. So they can able to communicate each other. Not network to network communication, device in the network. For example, this is the C1 and this is A2. if you want to communicate between this C1 to A2, okay, how you will be able to communicate? Like this. First go to switch or a hub, router, and you will send outside of your network, then router, like this, you will reach. This is also irritating me. Okay, like this. This is called a internetworking. What is internetworking? Communication between different networks. Communication between different networks. Okay. Guys, are you able to listen? Like screen is visible?
Yes. Yes.
Yes,
Can
sir.
I ask
Yes, sir.
four
Yes, no problem.
times?
You know.
Ask three, four
Yes, sir.
times. Do you understand or anything?
Yes, sir, visible.
Okay. So what is a network? Interconnection of two or more devices called a network. Something is missing here. Interconnection of two or more devices is a network. What is networking? Communication between the devices called a networking. What is internetwork? Internetwork is a connection of two or more different networks. Different networks. That is internetworking is a communication between different networks. Okay, so this is what I'm trying to say. This is we are connecting the devices. Of course, there is an internet kind of concept is there, but so we are connecting. The first point is connecting network. Second point is networking. Network represent connection. Networking represent communication. Okay. Without network, without connecting, we can't communicate. Wired or wirelessly, guys. So, sir, without wires also we can communicate. Yes, of course. Without wire means wirelessly also we are connecting. Okay, we are also connecting. So that's the point. Okay, network and networking. We can connect in a different ways, guys. We can connect the devices in a different ways. Okay, so physically we can connect the devices. We can connect devices different ways. Different ways. So the way of connecting devices. Devices means it can be a computer or maybe it is a laptop or it can be a printer, like any devices. The way of connecting devices is called physical topology. Physical topologies. So how you connected devices. How they will communicate, so how they will become a particular network kind of stuff. So there is a logical topology. Physical topology is about how you are connecting. Logical topology is based on the IP address configuration. Okay. So first of all, what are the physical topologies we have? Everybody remember? Bus topology, ring topology, mesh topology, star topology,
Hybrid topology.
very good, hybrid topology. Hybrid topology. Okay. There is a point-to-point topology, point to multi-point. These are all newly added kind of stuff, but it is there from so many days. Original topologies, since starting it is bus topology, ring topology, mesh topology, hybrid topology. All are remaining are hybrid topologies, but they are putting some names. Okay, so point-to-point topology, tree topology. So like that, there is so many topologies are there. For star topology, there is a extended star. This is star topology only, just it is extending to the star topology, not even a hybrid topology. Okay. Here I will draw some topologies, guys, mainly like two parts. We'll try to do it. While I'm drawing also, I will explain, but I don't type anything explanatory part. Okay, you have to get it from the PPT or some other resources. Okay, so one by one topology we'll see. Okay, just we'll take small sizes are enough because we have to put lot of things. Okay, in the small area. I have taken 4 systems, or maybe you can take 5 systems, no problem. I have 4 devices. These 4 devices okay, I have taken 4 devices and I am connecting these devices to a single wire. Okay, I'm connecting all these devices to a single wire. Okay, for example, this is A, B device, C, and D. Okay, if A want to communicate B or a C or a D, they will communicate it through this backbone wire only. It is very simple and easy to configure. They use a coaxial cable. They use a coaxial cable kind of stuff. Okay, so very simple to say it is a backbone wire. There is a backbone wire. Devices are connecting to this backbone wire, and these devices are communicating through the backbone wire.
Sir,
Yeah, tell me.
sir, the wire which is connected is coaxial cable. It can be optical fiber or any other things.
It can be optical fiber, but when bus topology design, that time optical fiber is not designed. Okay,
Yes, sir.
it's just a form. It can be a fiber optical cable. Okay, now we are getting this geo internet, right? So there are using that kind. That is comes under again direct a hybrid type, means a backbone wire will be there, and from that backbone wire, different home connectivity, office connectivity will come up. It's like a tree type.
Yes, sir.
Okay.
Sir, it is in bus topology. It may be on both sides, but connected in a wire in parallel.
It's not parallel. It's a kind of series type.
This is series type. Okay.
Okay, didn't get it. Okay, so now, okay, this is the main backbone wire, guys. It's a cable. Okay, so devices are communicating through this cable only, just like it's the olden days cable TV network type. So there is a cable TV guy is put a wire to home, right? And we are our TVs are connecting to that backbone wire only. Okay, this is a similar concept. It is, of course, it is very easy to configure, but difficult to troubleshoot, guys. If some issues occur, for example, wire got a broken like this. So AB can able to communicate, but further communication may stop. Okay, so it is difficult to troubleshoot because you have to find where is the actually wire got a broken. Okay, either you have to replace entire wire or maybe you have to repair the wire kind of stuff. Okay, so that is a bus topology kind of stuff. This is I have a PCs. I have a devices, and these devices are connecting like a one device is connected to another device is connected to another device, like a last device is connected to first device. So like that it form a ring, like A is connected to B is connecting to C is connecting to D is connecting to E is connecting to A again. So how they will communicate? A want to communicate it to B, sorry, A to D communication. How it will do? A send a packet to B, B to C, C to D. Okay, like this. If D want to send a packet to A, D to E, E to A. Okay,
It can be anti-clockwise. Is it possible?
it can be,
Anti-clockwise, like A to E, then D.
yeah, that is depends upon their configuration. So how to configure. So when A want to communicate it to D, so first send either A to B side or A to E side, clockwise or anti-clockwise side. Yeah, very good. That is the good point you are saying. Okay, either clockwise or anti-clockwise. Okay, if I
Sir, if
define
I
A to B type means I will communicate like this only.
sir, if
Just
I
in
want
case, yeah, tell me.
sir, if I want to send message from A to D, then we can't directly send to D. We have to send B and then C. Then it will be no the wastage of data or
Yeah, it is
privacy.
waste of data. Yes. If you want a more amount of data from another account, then it will take more time. Yes, right. Okay. So it is like that. It is lot of time it will take if you have more computers, not waste of data. It is exactly more computers are there, more time it will take to deliver a message or a information or a request. Okay. So I have 100 computers. your computer is, your device is 50 or 60. So think like this, how much time you have to travel. Okay, so that's the point. And it is easy to, it's not easy, but it is not depends upon any backbone wire kind of stuff. Okay, guys, if this wire is broken, for example, if this wire is broken, so what happened? A to B communication is there, but B to C or maybe this part communication will stop. Okay, or a device is down. For example, your C is down. Your C is down. So what happened? No further communication. Okay, no further communication. Of course, one way or other way means somewhat communication is happens. For example, C is down, not complete communication, not stop, right? So D, E, A, B are communicating like this. Okay, but this side communication is stopped. Of course, they found one more solution for it. One line is clockwise and another line for an anti-clockwise. That is called a double ring. That is called a double ring type. Means like this. Double lines.
సార్ ఒక హాఫ్ అన్ అవర్లో మాట్లాడతాను సార్ కొంచెం ఆఫీస్లో నేనే కాల్ చేస్తాను.
Excuse me, sir.
Yeah, tell me.
In bus topology, can we send a message to D to C like ring topology?
Yeah, they will communicate through backbone wire, no problem.
So we cannot send the message.
We can send A to B, B to C, C to D, D to A will communicate.
Okay.
So because
Okay,
it is traveling through this one only. All
it
communicate.
can be positive direction as well.
Yeah, it is in one wire. It's both direction. It will communicate, but it is off duplex mode.
Okay.
Okay.
So as you ask, if in case if I want to send message A to D, but I don't want to send A, B, C, D kind of stuff, then what to do? You have to form a double ring. So which one is nearest? Which way is nearest? I will choose it. Okay. AED is easy. ABC is easy. Okay. Like this. This is called a double ring topology.
Double ring means we have to make double connections.
Yeah, double connection for each device, like a two connections. Two connections.
Okay.
Yeah.
One
One
is for
connection clockwise, another connection for anti-clockwise communication.
okay.
Okay, but what are the faults inside? Okay, even this is also very good. Even one side of wire is broken, no problem. Still we can able to do communication. Okay, one wire is down. Okay, one wire is down. Still we can able to do communication. Okay, even device is down. Still we can able to further communication is not stopping. Okay, but there is a problem. Again, if new device is added, so I have to break my ring and add the new device again. I'm adding a new device. Again, I have to break my ring. Again, I have to configure all the devices. Okay. So that is a big problem with the ring topologies. Of course, nowadays no one is using this ring topology kind of stuff. Okay. Okay. So next topology is this is good one. Okay. So this is, I'm connecting every device to another device. Do anybody guess what topology it is?
Star topology,
Star.
I think.
Start of
Star topology, sir.
So when we see a symbolic representation of star, automatically what we think, it is a star topology, because of there is a name called a star topology is there. Okay, guys, it's not star topology for easy purpose. Yes, as if told, it's a mesh topology. Every device connected to all
Okay.
other devices. See, A is connected to B, okay, and C and D and E also. E is connected to A, D, C, B also. So they will draw in our classes in schools, colleges also. For making more easy to draw purpose, they will draw like this. And when we see this symbol, we thought it is a star topology and we forget other part. Okay, we write examination completed. Okay, see it as how much easy you can able to draw. Connections are completed. Okay, that's why they take only 5. Easy to drawing purpose. Okay, so this is not star topology, mesh topology. Every device is connected to all other devices. Okay, it's not depends upon any device or a backbone wire kind of stuff. A will communicate to B. A will communicate directly to C. A will communicate it to directly to D. A is communicating directly to E. Okay, it is a complex one, not easy. It's not much easy. It is a complex configuration. It is complex configuration. It is. It is a complex one. First, second, it is difficult to troubleshoot, but it is redundant. It means if one wire is down, no. Okay, so don't worry. So in mesh topology, guys, so it is a redundant. It means one wire is down. Only A to B direct communication is stopped. But A will communicate it to C, D, E kind of stuff, right? For example, D device is down, entire device is down, no problem. Remaining devices will communicate each other. Only D won't communicate. Okay. So a wire is broken or maybe a device is down, still remaining communication is going on. But it is a complex, difficult to troubleshoot. It is complex and difficult to troubleshoot. Okay. Next, why it is another point is here, guys. Another point as we told in a ring topology. In ring topology, we add one more device. Then again, you have to break the ring. You have to again reconfigure ring topology. Here in the mesh topology, you add one more device. Add one more device. What will happen? Again, you have to take a wire A to F. E to F, D to F, C to F, B to F. Again, you have to do all the wiring stuff. So number of wires increases if number of devices are increases. Okay, more number of devices, then very more number of wiring is required. Okay, so that's why it is a complex one. But mesh topology is using bus topology, ring topology may not
Yes,
using,
sir.
but mesh topology also using, but not in a regular network.
Hello.
Yeah, tell me.
Sir, if we increases the device, it the chances to decrease in the speed.
Speed is not matter because it's a one-to-one communication.
Okay.
Number of devices increases also, no
So
problem
if we,
because everything is one-to-one communication.
oh, it means if we increases the devices, only chances to increase of wire, not the decrease of
Wiring,
the, yeah.
wiring and NICs means you have to connect, right? You have to connect
Okay.
the number of that NICs adapters
But
should be.
sir, but
uh,
ring in divided another device, sir. The connection, sir, speed is very slow, sir, because of sir is a chain like process.
Yeah, of course, from A to B direct connection, but A to D is not direct connection, right?
So is it possible? It is depend on the processor of the system as well.
That is processing. Let's don't go to that work. Okay. Okay.
Okay.
Yeah, of course, every system only. But point is, mesh topology, no problem. Direct A to B communication, A to D communication, A to C communication. Okay. But in a bus and ring topology, the communication is going through that backbone wire in the bus means all packets are traveling in the same wire. In a bus topology. In ring topology, so you have to send a packet over one device to another device, other device to other device. Finally, we reach the destination. Okay. So speed wise, that is an answer. But in a mesh topology, it is a complex. Lot of wiring, lot of NICs required to connect. More number of devices increases, more number of connections, more complexity increases. But it is reliable, guys. Unlike bus topology, ring topology, it is a reliable means if one wire is broken or maybe one device is down, remaining communication is going on. For A to B, the wire is down. A to B communication is stopped, but A is communicating to other devices. For example, D is down, D PC is down. Only D PC is not communicating. A, B, C, E communicating each other. Okay. So this is based on redundancy. But there is a one more problem is there, like a ring topology, but it is difficult to scaling. Means more number of devices we can't put it. If you put additional devices, again we have to go to each and every PC, add a one more NIC and connect it to our machine. Okay, then it is become it's difficult to scalable. Means adding more devices or extending our topology is become difficult. Okay.
Sir, what is NIC?
Network interface card, your network card. So where you connect a wire. Okay, that's the point.
Yeah. Thank you, sir.
Next one is, guys, of course, mesh topology is also using not in our regular LAN communication. Not in our regular LAN communication, but mesh topology is using where mesh topology is uses, in a server's rooms, storage area network means SAN storages, SAN type of storages, servers, core networking areas. People use mesh topology for redundancy. Means one server is down, no problem. Other server will give you a service. Highly available networks. So generally we use mesh topologies. Okay, not in our regular network communication. Okay, so I don't have a space down, so then I will put remaining things in a separate one. These are the first three topologies. Star topology and all, I will put it in another drawing. So this can be a hub. Hub is a device, switch is also a device. Okay, so you can use hub or a switch for this one. Okay, so I have a devices. I'm connecting the devices to this centralized device called a hub or a switch. Okay, so every device is communicating through this centralized device. All communication going to centralized device. A to B communication or A to D communication or B to E communication or F to C communication or C to D communication, whatever it is, all we are communicating through this centralized device only. Okay. It is very easy to configure and very easy to troubleshoot. It is a very easy to configure and very easy to troubleshoot. This is a star topology. Okay, it is called a star topology. Easy to configure, easy to troubleshoot, but not much redundancy, guys. But only one thing: if a piece is down, but remaining devices will communicate each other. A is down, no problem. The remaining devices will communicate each other. Or this wire is down, wire is disconnected. Only DPC is unable to communicate. Remaining devices will communicate each other. Okay, but the centralized device called a hub or a switch is down. Total communication will be stopped. Of course, that is a big problem. But simply, guys, to understand, it is very easy to troubleshoot. Means you will know where is exactly an issue, then you will troubleshoot according to it. In a bus topology, ring topology, you have to search where exactly issues occur and you have to troubleshoot according to it. Okay, so here it is. We'll very easily know is a wire related, device related, or a centralized device related issue. So we know already, so then we can able to troubleshoot it. So this is the star topology. Guys, understand?
Yes, sir. Got it.
Okay, this is another star topology. This is another star topology, means another segment or a network. Okay, this is one segment, this is another segment or another network. Both are in a same location, same room only. Think like this: same room, same floor, same building kind of concept it is. Okay. Okay. I will put some different A, B, C, D, F, G, H, I, J. Okay. Okay. This is another segment or another network. So our we can connect like this, but we need this kind of connectivity. The dotted line that is representation of a crossover cable. Just for understanding, guys, just think like this: I connect this switch to another switch. Now total it is become single segment or a single network. Both the networks are in same building or same floor or same room. Okay, we are connecting these two things. This is an example like I have a lot of devices, 30 computers are there, 50 computers or 100 computers are there in the same building. I want to connect, but one single switch is not enough. So I need a multiple switches to connect all these devices. So I will connect one switch to another switch and create a single large network. Single large network. So that is our extended star topology. This is concept of extended topology. So star topology, easy to configure, easy to troubleshoot, easy to scalable. Scalable. What is a scalability? Ability to increase size or infrastructure or like that. Size is the best example. Okay. This is extended star topology. Yes, understand what is star?
Yes, sir.
Yes, sir.
Next. This part is very simple point only. Okay. So I connect a switch to a PC or in a ring topology, in mesh topology also, I connect one device to another device, right? So this is simple one-to-one is simply can say it's a point-to-point topology. So you are connecting one device to another device directly. It is a point-to-point device. So one PC to another PC, one PC to another switch. Okay. One router to another router. Okay. So this is, we call it as a point-to-point. And searching for a certain shapes. This is thunders. I don't get this one. Okay. So what I said, it is point-to-point means a device is connected to another device. It's very simple. Usually we use this concept here like in a WAN communication type. Another one is point to multi-point means a device. You can see the switch is connected to multiple devices. The same concept. One device is connected to multiple devices. Symbolically it is showing like one single point, but guys, so it's a different ports are there. This is point to multi-point. One device is connected to multiple devices. Example is this one.
So it's like a star topology.
Yeah, it is an example of one of the example is star topology. Okay. this device is connected to multiple devices. Okay. And this point we are missing this one. That is enough. Okay, guys, this is star topology, ring topology, mesh topology. These are the topologies. You can see. So hybrid means it's a combination of two or more topologies. Is a hybrid topology. I'll give you one more topology, that is where it is located. Okay, I don't draw T topology, just take the T topology. Okay, there is a backbone wire. To the backbone wire, different type of connection. This is another like a bus topology only, different connections are there. But in bus topology, we are connecting to directly a device. But here we are connecting to different topology. Again, this is star, this is star, this is star, like that. Okay. So as you asked me, Geo fiber net is work like this only. There is a backbone wire, and one wire is from there, it is connected to home. There it is, internet is distributed. So one example for a star topology. Okay, so that's the point. Next one, we will discuss about a type of networks and other things, guys. Please take a break. Come back at 12. Yeah, tell me.
Sir, it's a backbone of a system, yeah, wire. Then one router connect and three systems, S1 like a router and three are systems. Hello.
Yeah, one second. You are saying backbone wire to?
Sir, in tree topology, in tree topology, one backbone cable connect S1 like S2 is a router and A, B, C is a connection.
A, B, C are a computers, think like a computers or a devices like mobile phone or maybe, okay. S1 is like a switch, maybe a router.
Okay.
Okay. The next part, guys, we will try to discuss about a type of networks, Internetwork, internet, and if possible devices also. Take a break, come back. I'm muting for some time.